16.3, solving equations with variables on both sides, okay? Now, it's really simple. It's very simple to do this, but you guys haven't seen it before, okay? So let me ask you this. Kate, what does it mean to solve?
Get the variable by itself.
Get the variable by itself. But Connor, how many variables are in this equation up here?
There are two.
So, William, which one do I get by itself?
You get,
Exactly. That's our problem, isn't it, William? All right? Because we got variables on both sides. Which one do we get by itself? Well, I tell you what, William, we want to get rid of one of them. Now, you get to pick. Which one do you want to get rid of?
both of them.
Not both of them.
10.
Okay. How do I get rid of 10n? This is algebra. Remember, if I do it, I can do whatever I want as long as I do it to the other side. How do I get rid of 10n? Maddie?
Divide by.
No. How do I get rid of 10n, Hank?
Minus 10n.
I subtract 10n. But remember, I have to do it to the other side. Okay? So now, Maddie, what does this turn into?
That was into
Negative 3.
Negative
3n.
3. Negative 3n.
Okay? What happens to those, Maddie?
They cancel.
They cancel out. And
It's just negative 3n and minus 5.
minus 5 is equal to what?
Plus 13.
Positive 13. Now this looks just like the stuff we did last night, doesn't it? Matt, what would you do next?
Add 5.
Add 5 to both sides. All right. And Matt, what happens to those two things?
Cancel out
Negative 3n. And what do I get when I put those two together? 18. Bolton, what do I do from there? Divide by negative 3 on both sides. All right. And T, what do I get on this side?
N.
Good. N. That's better. And what do I get on the right side, T?
15.
We're not subtracting 3. It's 18 divided by negative 3.
Negative 6.
Perfect, T. Thank you. N equals negative 6. If I've got variables on one side, on both sides, I just pick one to get rid of. Right? So then I only have one to get by itself. Okay? Now, I'm actually going to skip the second example. I want to come back, we'll do that one last. Let's skip to the third example next. Here we go. Now we've got, sometimes we get these special solutions. Okay? Joanna, it says the number of solutions when you solve an equation. It says number of solutions. When you solve an equation, you may find that it has no solutions or that every number is a solution. Okay, well, let's see what they mean by that. Okay? Example number 3 says, solve this. What would you do, Joanna? Yeah, because I always, what before I solve? I always simplify before I solve, and that's PEMDAS. Okay, so let's distribute. What do I get, Joanna? That's 10x. Good. And then what? 5 times 1 is plus 5 is equal to 10x. Now I want to stop right here for a moment. Okay? And Sean, I want you to think about this. Do you see this number? It says 10x. Sean, I'm sorry. We were talking about this. You see 10x right here? Do you agree that it's the exact same thing as that number?
Yes.
Okay. But wait, on this side, I've added 5 to 10x. How can I add 5 to 10x and it still be 10x? Is that possible?
No.
Okay, let's see what happens. Well, let's see what happens. Okay? Now, Sean, if I were going to solve this, what do I need to do next?
You would have to get 10x by itself.
Well, right, I want to get them together, don't I? Just like I did in the first example.
You add 10x plus 10x.
Well, I don't want to add them because that'd give me 20x. What would make the 10x go away?
Minus 5.
Not minusing.
10x.
Minus 10x on this side and subtract 10x on this side, right? Okay. But, William, what happens to these two?
They cancel out.
They cancel out and I'm left with what?
X plus 5.
Is 10x minus 10x, does that equal x? No. A number minus itself
That'd be
is,
5.
it'd just be 5, right? So I get 5 here. What happens to those two, Truman?
They cancel out.
And what am I left with?
X.
Not x, you said they canceled out.
So just 1.
Not 1,
0. 0.
I'm left with 0. Now, Kadia, this says 5 equals 0. Is that true? No. Kadia, whenever I get an answer that looks like this, that means there is no solution. Here's what it means. When we go back up here, let me rewrite this so that we can see it. Okay? We said that this was 10x plus 5 is equal to 10x when we distributed, right? There is no value for x that I can plug in that will make 10x plus 5 still equal to 10x. Do you see that? Do you see how it doesn't make sense, really? 10x plus 5 more is equal to what it was before I added 5. That's impossible, right? There's no solution to this equation. There's no number for x that I could plug in to make it true. Now, let's look at the next one. Okay, let me move this down a little bit. It says solve 6x plus 2 is equal to 2 times 3x plus 1. Hey,
Yes.
it says solve. What does that mean?
The variable by itself.
That's right. But I always what before I solve? Simplify. What can I do here, Maddie, to simplify?
Well, I'm just going to do the top.
Exactly. So 2 times 3x,
2 times 3x is 6x.
2 times 1,
Is 2.
good. And on the left side, I've got 6x plus 2. Does anybody notice anything? What do you think, Joanna? There are variables on both sides. That's true. But Sarah, what do you notice?
There's 6x on the 6x plus 2.
They're exactly the same on both sides. Well, that's interesting. Remember before, I pointed this out and we said, oh, that's kind of interesting. I wonder what's going to happen. And then we saw it turned into something. Well, this is interesting too. Let's see what happens. Remember, if I have a variable on both sides, what do I need to do, Kadia? I'm going to subtract 6x to try and get rid of one of them, right? But I have to subtract 6x from the other side. Connor, what happens to those two?
They turn into air.
And what am I left with, Connor?
You're left with positive
Positive 2. And what about these?
2. They also turn to air.
And I'm left with?
Positive
Now let me ask you this. Sean, is this true? 2 equals 2. Yeah, that's true. It's always true. When I get a true statement like this means all numbers are solutions. Okay? X equals all numbers. Remember back here, we can say that X has no solution or that every number is a solution. Well, that's what this example is. It doesn't matter what number we plug in for X, Truman. I'm still going to get the same number on the left side as I do on the right side, regardless of what I put in for X. Someone earlier today said, well, what if you put in a billion? Okay, well, that would be 6 times a billion, which is 6 billion, plus 2, right? So that's 6 billion 2. Okay, now, if I plug it in on the other side, it's 3 times a billion, that's 3 billion, plus 1. So that's 3 billion plus 1, but what happens when I multiply by 2? 6 billion 2. It doesn't matter what number I plug in for X, it's always going to work. Okay? Because it's the same on both sides. Well, no matter what I plug in, it's going to always turn out the same, isn't
They
it?
already have the same amount of variables.
Now, let's go back and look at this word problem.
This is the
Okay?
last one.
So last one. And it says, the Spanish Club is arranging a trip to a Mexican restaurant in a nearby city. Those who go must share the $60 cost of using a school bus for the trip. The restaurant's buffet costs $5 per person. How many students must sign up for this trip in order to limit the cost to $10 per student? Okay, well, they've actually given us a little model here that we can work from. What do we want the cost per student to be, Joanna?
10.
Okay, we want the cost per student to be 10. We know that number, right? Now, what are we looking for in this problem, Kate?
How many students?
We're looking for the number of students, right? So when they give us number of students here, is that going to be a number or a variable?
Variable.
A variable. I'm going to put t instead of s, because s sometimes looks like 5. So 10 times t is equal to the cost of the buffet. What is the cost of the buffet, Maddie?
$5 per person.
5, okay? And it says times the number of students. Well, how do we represent the number of students, William? T, okay? Plus the cost of the school bus. What is the cost of the school bus, Sarah? $60, okay? Now I think we filled in everything. What's the first thing I need to do in order to solve this equation? Joanna?
Subtract 5t and 5t.
I like it.
And from
But I have to do it on this side too, don't I? Nice job, Joanna. Perfect. So what is 10t and negative 5t, Joanna?
it's negative. Wait. Oh, yeah,
It's 5t. What happens to this over here, t? What happens to those two things?
I cancel out.
And I'm left with what?
T equals 6.
Oh no. 5t minus 5t doesn't leave me 1t. What happens to those two things?
I cancel out.
Yeah, and that's what we wanted. And what am I left with on that side?
60.
60. Okay, good. Connor, what do I do now?
Now you would get t by itself, but I got a question.
How do I do that?
You would divide 5 and t.
All right. And I get t equals 60. Yep.
No.
Oh. That was
What do I need to do, Connor?
Divide 60 by 5.
You didn't say that.
Oh, I'm sorry.
Divide 60 by 5. What is 60 divided by 5, Mac? 12. Now, 12 what? 12 cows?
Yes.
12 what, Truman?
Watermelons.
12 what? No, not $12.
12 shillings.
Maddie?
12 students.
12 students, for those who have been watching the problem. Okay? Good. Nice job. I think you're ready for your homework, but I need to pass it out to you.
Wait.